Hey everyone, welcome back to Data Mining and Predictive Analytics. I am Dr. Bolton, and today we're going to be talking about the heart and soul, the power of SQL, and how we can really access multiple tables and combine queries using subqueries and nested selects. So let's jump into it. So subqueries and nested selects. A subquery is really just a query that is inside of another queries. And so subqueries can actually have subqueries and so on and so down, as many levels as we actually wish. But it can also be used in different areas of our select statement. Okay, so if I have select the columns from a table where the column is equal to, I can insert another select statement here after the where clause. It can also be inserted at the table after the from clause, or for the column after the select clause. So we can use them anywhere in here and embed these additional selects anywhere within our select statement. So why do we want to use this? Imagine that we have this particular query where we want to retrieve a list of employees. Also, we're going to use this table here, this employees table, as our example. If we want to retrieve a list of employees who earn more than the average salary, we might use this select statement, select all the columns from the employees table where the salary is actually greater than the average salary. You might think that's a perfectly legit query. Problem is that this is going to actually return a result, an error, all right, because we can't do an aggregated average salary where as the criteria to a where clause. So instead, we have to embed a additional nested select statement after the where clause. So if I have this select statement after this, I think I changed this up. This is less than, but you get the same idea. From the employees table, where the salary is less than the average salary, we have to use the parentheses here to embed another select statement that says select the average salary column now, which is just an aggregate column from the employees table. It'll create the aggregate and then compare the salaries against that aggregate. You might also be thinking, well, what if I just create another column as the average salary column? Again, we would get another error actually indicating that we would need a group by clause in order for us to be able to aggregate this employee ID and his salary. All right, this is an aggregate column. We need to aggregate salary and employee ID. We don't have that, and so we'd return back another clause saying, hey, well, how do you want to group these columns by? So instead of doing that, we can actually embed another select statement, select the average salary from the employees table as, and rename that as average salary, and embed that as an non-aggregate column, and that should be just fine for our select statement. Another subquery that we can do is after the from clause. All right, so we can substitute our table names, all right, with an additional subquery and create what we call a derived table or a derived table expression. All right, so this allows us to create derived tables from that main table in which we want to maybe create more complex views. So in this case, select all the columns from, instead of the main table, we're selecting just the employee ID, first name, last name, department ID from the employee main table, and we'll just call it imp for all right? And that'll be our derived table that we're going to select all the columns from. All right. So far our discussion has really been on SQL statements that have been mostly just accessing and querying one specific table. The real power of relational models is how we store data in many related entities. So now let's really take a look at how we can actually construct queries from multiple tables. So there are many different ways to access data across multiple tables. And for our discussion, we're really just going to look at three. So one, accessing data using subqueries, just like we were discussing. All right. Two, we can implicitly join multiple tables based on a selected criteria. And three, using these specific join operators, which have specific functions on how to join multiple tables. Again, we're going to use our table example here as our employees table, and now we're going to add in this departments table. So SQL also provides the subquery technique, which involves placing an inner query, another one of those select queries within an outer query. And you can use this either after the where clause or the having clause of another outer query and so forth. All right. But this inner clause allows us to set conditions for which we are searching within another actual table. So in this case, we're selecting the department ID department from the departments table, and we're using that as the where criteria for us to include the department ID. So we're going to select all of the columns from the employees table, all right, where the department ID column includes, all right, the select statement here. So this department ID has to include the department ID department. So that means that it's going to return back, all right, all of the columns where the criteria is that this number in the department ID depart matches the department ID in the employees table. Does that make sense? I hope so. Another example here is to retrieve only a list of employees from a specific location. So here we're going to select all the columns from the employees in table where the department ID includes another select function here, another select query, where now the department ID department from the departments is now has its own criteria where the location ID is L0002. All right. So we're only going to get the department ID department value from the department's table where the location ID is L002. That's this 5. And then the outer join or the outer statement here, select statement, is select all of the columns from the employees table where the department ID is only going to include actually this value of 5. So it only return back these two and all the column information. Lastly, we can do this the reverse way, right? We can do it onto the departments table. So select these department ID department and the department name from the departments table where the department ID department includes, all right, select the department ID from the employees table where the salary is greater than 70,000. So only where it's greater than 70,000 will we include the department ID to then go back and pull the department IDs that match over 70,000. So in this case, it would be 2 and 5 where this is matching, okay? So another way we can join tables in our statement is by implicitly stating which tables we want to join in the table part of our statement after the from clause. This is oftentimes called a full join or a Cartesian join, but basically we're going to mash up those two tables and join them by rows, where every row in the first table is joined with every row in the second table. All right. So if I take my employee table and my department table, row 1 would match up with row 1 of each one of those tables, row 2, row 3, row 4, and all of that. You can imagine this can sometimes be a little bit troublesome, especially if you have unmatched rows where you have, say, I have more rows in my employee table than I do in my department table. You're going to end up with this uneven amount of rows from each one of those tables, which can cause you problems later down the road when you're trying to actually do any kind of analysis. So even though it is a possibility to do this, oftentimes you want to set other limitations in your criteria. But this is easy enough to do by selecting all of the columns from the employees table, comma, the departments table. All right, so very easy to do that from two different tables by implicitly saying which tables you want to draw your information from. So from that, we can also add in additional operands that are additional criteria for which we want to pool those rows. All right, so we don't end up with such unevenness. All right, so select all of the columns from the employees and the departments table where the employees dot department ID equals the departments dot ID dot department. So we haven't talked much about these dot operators, these dot operands, but this allows us to implicitly say this is the table dot this is one of the columns. This is the table dot this is one of the columns. And because oftentimes the names of the tables can be pretty long, oftentimes we use aliases for the table names. And to do that, after the from clause, we need to explicitly say what is going to be our short alias. So from the employees table, I'm going to shorten that, no comma, all right, so just a space. I'm going to shorten that to E as my alias, comma, my department table, and I'm going to shorten that alias to a space D, all right? And now I can explicitly say where my E table dot department ID equals my D table department ID dep. Again, we can do this even at the columns, all right? So I can select the columns from the different tables as well, and then use those operand aliases as well. So here, my employees table, I want to select the column here from my employees table. I want to select the column department name from my department tables. And then from my employees, I can explicitly name E and explicitly name department D, all right? And then have my criteria of my where clause. And so this is just executing this back onto the specific columns and not like here. In this one, we selected all of the columns. So if I want to select only certain columns from those tables, I can implicitly say that, after the select statement as well. Again, we can add prefixes to this by adding in the E dot and the D dot if I've implicitly told SQL how I want to shorten these table names. And the last way we will discuss combining two or more tables are looking at the join operators. And these are different functions that are built into SQL to be able to combine two or more tables and are used quite a bit. And so we're going to look at a quick table here, a little relational table where we had the authors, the borrowers, and the books of these authors. And if we wanted to know which borrower has a copy of a book on loan, we would need information from 3 different tables. So join operators are all about using the primary key and the foreign keys of these tables and these entities that we set up when we create our ER diagram, if you recall that a few weeks ago when we did those. All right, so remember, a primary key uniquely identifies each row in the table, whereas a foreign key refers to a primary key in another table. So every single table, all right, has to have some kind of primary key, some kind of unique identifier, all right? Whereas we don't necessarily need to have a foreign key in a table, all right? You can have multiple foreign keys in a table, which refer to all different other entities that you have within your database. All right, but you can only have one primary key for each table. All right, so we see that here in this diagram. Join operators then act on these different keys. All right, and so we can match up the different keys, the relationships between these entities, to be able to join them in unique ways. All right, and so if I want to know which borrower has a book out on loan, I can use the borrower ID, which is that unique primary key from the borrower table, and then compare it to the borrower ID of the foreign key in the loan table. So these two IDs should match up, all right, between these two tables. So there's a relationship between these two tables. And if I compare these two, wherever they match, all right, or equal to one another, all right, that's going to be my relationship. All right. A couple different types of joins. All right. The most popular one is called an inner join, which takes those two tables and then based upon that criteria of the foreign and primary keys, we have a relationship and will return back those rows that match that criteria, that match that relationship. And then there are outer joins, and then there are a few different flavors of outer joins, which we'll discuss here in a minute. So an inner join joins those two tables based upon that criteria. And the syntax for all our joins are what type of join you're going to use, and then what is the criteria for that join. And you use that that keyword for that is on. All right. So here I'm going to select the columns that I want to view from the borrower table and from the loan table. And I'm going to say, all right, which one is you got to specify which table you're going to start with. And usually whichever one you're going to join another table to that table. All right, so from the borrower table, I'm going to interjoin the loan table. All right, and this is done based on the criteria of that borrower ID in the borrower table and the loan table being equal to one another. All right, and what I get back is the columns, all right, that I specified. All right, and then the criteria of the borrower ID and the loan ID being equal to one another. So D1, D1, D2, D2, D3, D3. So these match, and that was the criteria that I set on the inner join. So it only returns back that criteria. An inner join, you can do this. The cool thing is you can do this on multiple tables, right? So I can just keep inner joining multiple tables into my query, all right? So select the names of borrowers have book on loan, and which of the copies of the book do they have, all right? So here's my columns. I'm going to return back last name, copy ID, and the status now from this third table. All right, we're going to start with the borrower table. All right, and then interjoin the loan table based upon the primary key and the foreign key. All right, and then add another interjoin that's going to add the copy table, and that's going to be, notice that there's a relationship between the loan table, all right, which has a copy ID. All right, from the copy table. All right, so here's the copy ID, which is my primary key, and the foreign key also exists in this loan. So there's a relationship now between these two tables based upon the copy ID. So based upon that relationship now, I can add in that extra inner join. So now I'm interjoining the table based on the loan copy, all right, and the copy ID in each one of those tables. If I look at what that should look like now I get the last name, the ID, and now the status, all right, which is this column here that I specified returning based upon this ID, all right. Again, it's all about the primary and foreign key relationships, or the relationships between these entities that the joins are acting on, all right. The outer join, all right, there's a left outer join. This is going to return all the rows from the left table and then any of the matching rows on the right table. Again, based upon the IDs, I'm going to, between the keys, I'm going to use the borrower key from the borrower table and the borrower ID from the loan table. We select the columns that I want to see. We're going to start with a bar or a table, all right? And then left join. Again, the syntax is now left join on the bar ID from the bar table and the bar ID, the foreign key in the loan table. So what I'm going to get back now is all of the rows from my borrower table, all right, which exists, all right? So I get my columns back, and then I get all the rows, and then only the rows that are going to match, all right, my bar ID, all right? So obviously there were no bar IDs in my loan table for D8, D6, and D7. So because these didn't match up, all right, I get back these null returns, all right? So I'm going to get back these null returns because nothing matched in my loan table for my borrower ID, all right? These borrower IDs only existed in this table. They didn't exist over here in my loan table, all right? For the right outer join operator, all right, this is going to return all the rows from the right table and any matching rows from the left table, all right? Again, select my columns, all right, start with my bar or table, and now I'm going to right join the loan table based upon the primary and foreign key. Here I see that I get all of the rows back for my loan table, and the only ones that matched, all right, from the borrower ID, from the borrower table, were those rows. So notice that 6, 8, and 7 or whatever, didn't match, so they don't get returned. And so instead of having those nulls that I'd have to deal with, right, in some kind of way, which we'll talk about in the upcoming weeks, how we're going to process nulls and missing data, right? But this is a way that just by changing the join and the way that we did it, if we had used the left join, we would have introduced missing data, all right, into our query. But by using a right join, we now don't have those missing values, those null values that we have to deal with, all right? So consider that when you're using these joins. And then a full outer join operator is going to return all the rows from both tables. So just like our full join, all right, we use a full join operator. If I do that, I'm going to start with the borrower table, full join the loan table, and then we'll do this based on the primary and the foreign keys from both tables, so we get back all rows. So now I got 6, 7, and 8 back here on my borrower table, and then on my loan table, I've now got those null values introduced. So using a full join on this particular query would have also introduced null values. So if I were trying to figure out, all right, which one of these was the best to use, all right, for this query, I would want to use the one that didn't introduce any kind of missing data. And for that, it would have been the right join, all right? All the other joins would have introduced null values or missing data. So that's a little introduction into joins and really accessing multiple tables, using the power of SQL to be able to manipulate, all right, and access data from multiple different tables to create these views and to extract information, extract data from multiple tables. All right, that's all I got for you guys today. Hope you enjoyed it. If you got any questions, contact me. But other than that, have a great day, and I'll talk to you later.